Hello students, welcome to the second year class of Computer Engineering and Information Technology for the data structure using C, and our subject code is 22317.
Today's video's learning outcomes are Introduction to Queue. As we are studying the chapter number 3, Stacks and Queue. In the previous video, we have completed our stack topic. Now we will going to learn about queues. So in the queues, there is the introduction to queue representation in memory using array, then queue as ADT, then queue operations, that is insert and delete, and queue operations condition, that is queue full, that is, or queue overflow, or queue empty, queue underflow. And see, this is the introduction of queue. So queue is a linear data structure. It is used for temporary storage of a data values. A new element is added at one end called the rear end, and the existing element deleted from the other end called front end. Queue has the first in first out property. This is example of a queue, means array representation of a queue: 23, 53, 89, 54, 44, 10. This is the 10 is the front of the queue and 23 is the rear of the queue. So a definition of queue is a linear type of a data structure in which insertion can take place from one end called the rear of the queue, and the deletion can take place from another end called as the front of the queue. So example of a queue is waiting for a bus, queue waiting for a bus, then tickets, then queue for means any type of queue is the example of a queue. Means in the queue who is the first, uh, he or she got the first chance to for to get in the bus, or for the ticket. Means it is the concept of the first in first out principle. Means it works on the first in first out principle. uh, as the stack is the first in sorry, last in first out principle, that is LIFO, and this is FIFO. It is also called as FIFO, FIFO, that is first in first out principle. So this is our example again, same example, that is 23 is rear and 10 is the front. Okay. This is our daily life example. Q is for ticket, and uh, in this row, in this queue, there is a means who first inserted is first remove. Means insertion can takes place from rear end and deletion can takes place from front end. Means insert and remove. This is the array representation of a queues. A of 0, A of 1, A of 2, A of 3, A of 4. These are the array index, and 12, 9, 7, 18 are the elements in the queue. So in this array representation, 12 is the front and 18 is the rear. Means A of 0 is the 12 and A of 1 is 9, A of 2 is 7, A of 3 is 18. So rear end, 18 is the rear end and 12 is the front end. Okay. Now Q after insertion of a new element, rear is A of 4 and front is as it is. Then deletion after an element is front is the 9, means front is A of 1 and rear is A of 4. So the Q as an ADT, that is abstract data type. A Q of a type T is a finite sequence of elements with the operations. That is first is a make empty queue. To make the queue is an empty is empty, to check whether the queue is empty, or return true if queue is empty and return false otherwise. Is full, to check whether the queue is full and return the true if queue is full and return false otherwise. In and queue, that is q comma x, to insert an element x at the rear of the queue if and only if queue is not full. Then dq means to delete an element from the queue of the queue if and only if queue is not empty queue. Traverse of queue means to read the entire queue, that is display the content of the queue. Means these NQ and DQ conditions are used when the queue is full or queue is empty. Now we will see operations on queue. There are two operations on queue, insertion and deletion. So first is our insertion. So insertion means placing an atom in a queue is called insertion or NQ, which is done at the end of the queue called rear. Means in the queue insertion can take place from rear end. See here in the diagram we can see that rear end means insertion. After inserting the elements, queue is increased by 1. We will see algorithm. See, this is the algorithm for insertion. Step 1, if rear is equal to max minus 1, then write Q is overflow. Go to step 4, end of if. If front is equal to minus 1 and rear is equal to minus 1, set front is equal to rear is equal to 0. Else set rear is equal to rear plus 1. End of if. Then step 3, set Q of rear is equal to num, then exit. See here, initially the initially the front and rear of the Q is minus 1, and the max minus 1 means it is the array representation. That's why the total number of elements are n minus 1, that is or max minus 1 means maximum size minus 1. If array size is 100, then array index starts from zeros. That's why the total numbers are 0 to 99 means max minus 1. And initially front is equal to minus 1, rear is equal to minus 1. After inserting a new element in the queue, rear became rear plus 1 means minus 1 plus 1 equals to 0. That is, our first element is at a of 0th index. This is the example of insertion in a queue. Here front is equal to rear is equal to minus 1. So initially queue is empty. Then after inserting 10 elements, a of 0 is 10. In this, front is equal to rear is equal to minus 1 means rear is equal to rear plus 1 means r is equal to minus 1, then minus 1 plus 1 equals to 0. That's why a of 0 is equal to 10. Again we have to we will insert the element 20. Then again rear increment by 1 means now rear is 0. So 0 plus 1 equals to 1 means a of 1 is equal to at a of 1th index there is a 20 element. Okay. So this is our now deletion operation. Deletion means removing an atom from the queue is called as deletion or dequeue, which is done at the other end of the queue called as the front. See here in the diagram we can see that there is a front end, and from that front end we have to remove the elements from the queue. Means we can't remove the element from the rear. Okay. So this is the algorithm for deletion operations on queue. Step 1, if front is equal to minus 1 or front is greater than rear, write a Q is underflow. Else set the value is equal to Q of front. Front is equal to front plus 1. End of if. Exit. So while insertion, as rear is incremented by 1, like this in the deletion, while deletion front is incremented by 1 also, means initially front is equal to minus 1. See here, this is the example of a deletion of a queue. In the queue there is a of 0, there is a 10th element, and a of 1 there is a 20 element. After deletion the queue became a of 0 is a of 0th element will be removed, means that will be delete, and remaining element is a of 1 is equal to 20. Means in the starting there is a f is equal to 0. So while deleting, f is increased by 1 means f is equal to 0 plus 1 means 1. Now front is equal to 1 and rear is equal to 1 means a of 1 is 20 and 10 element will be deleted from the queue. We have to remind that while insertion rear incremented by 1 and while deletion front incremented by 1 in the linear queue. Okay, this is the linear queue. And initially front is equal to minus 1 and rear is equal to minus 1. So Now these are the queue operations conditions. Queue full means queue overflow and queue empty means queue underflow. These are the conditions for the queue. Our overflow condition means when the queue is completely filled and more elements are to be inserted, then the overflow condition arises. Rare is equal to max means the overflow condition arises, means there is a queue full, that's why we can't insert a new element in that queue, and this condition will be checked while inserting the new element. Now underflow condition is checked while deleting the element from the queue. When the queue is empty and we need to delete the element, then underflow condition arises. In the underflow condition, front is equal to rear is equal to 0. These are the queue condition, that is queue underflow and queue overflow. Okay. Now there are the different types of queues. There are linear, this is the linear queue, then circular queue, priority queue. The circular queue and the priority queue we will learn it in the next video. Thank you.